Okay, so for our Chapter 1 review, I have some specific things that we'll go through, and there is a review sheet in your packet that has the stuff that's going to be on these slides. But also remember that the first day of the chapter, I gave you a bookmark that had all of our objectives on there. And I said you could think of this like a checklist for preparing for the test. So if you can read down and say, yes, I'm good with that, yes, I'm good with that, yes, I'm good with that, you should feel pretty good about going into the test. Okay? So you can use this as kind of a checklist and see maybe places that you might need to study or practice a little bit more. Also, I'm going to have some specifics in our lesson here today. So the first thing is you should be able to list the 4 parts of a mathematical system. For example, it is possible that the first question on your test might ask you to list the 4 parts of a mathematical system, perhaps, maybe. Hint, wink, wink. Okay? You should be able to list the 4 parts of a mathematical system for the test on Friday. So those are undefined terms, defined terms, postulates, and theorems. I will not take off for spelling. Theorems is kind of a weird word. Students often misspell it. I myself usually just write THM and try to get the point across that way, and that's fine. But you should be able to create this list for the test on Friday. These are the 4 things that make up a math system. Vocabulary. There will be a portion of the test that is on vocabulary. It will not be matching. You will need to write definitions for words with words, not with pictures. Okay, that's tempting in geometry to start drawing me pictures of what I'm asking about. But in geometry, language and precision of language and saying exactly what we mean is a very important thing. So I'm going to be looking for words, not pictures. For example, if I ask you to define a segment and you draw me a really nice segment, you're not going to get any points for that. You need to use words to tell me what a segment is.
Is segment defined?
A segment is defined.
Will you put any undefined?
I could. So you need to know which terms are undefined. There are 3 of them. They are point, line, and plane. And if I ask you on the definition portion of the test to write a definition for one of those 3, you should say undefined, or no definition, or I can't. Okay? You should not just leave it blank, because then I don't know whether you didn't know or whether you knew but just didn't write anything. Okay? So if I ask you to define point, line, or plane, you should tell me that it is actually undefined. From section 1.2, you should be able to define collinear and coplanar. Collinear are points that are in one line. Coplanar, points that are in one plane. Your definitions must use words. They don't have to be exactly the same words as I had in the notes. Okay, so you don't have to memorize the definitions word for word. But they need to get the point across. From 1.3, you should be able to define segment, ray, opposite rays, congruent, and midpoint. A segment has 2 endpoints and all the points between. A ray has 1 endpoint and goes forever in one direction. Opposite rays are 2 rays that have the same endpoint, go forever together to make a line. I'm saying these quickly. You don't need to write them down. They're in your notes packet. They're also in your textbook, so you can look them up there to study from. Congruent means that they're the same type of thing and they're the same size. So 2 segments are congruent if they are the same size as each other. Midpoint, we need to be really careful with. The definition of midpoint is that it makes 2 congruent segments. Okay? The definition of midpoint is that it makes 2 congruent segments. Something the midpoint definition does not say is that it cuts the segment in half. Okay? This may seem nitpicky to you because it's true that it does both things. But in the next chapter, we're actually going to have a theorem that tells us that a midpoint cuts a segment in half. The definition says it makes 2 equal pieces. Okay? So again, precision of language is saying exactly what is going to be important to us this year. So make sure you know that a midpoint makes 2 equal segments or 2 congruent segments. If I see anything about a half in there, it's not going to be worth full credit.
Are we just gonna have like a blank line that we can write in?
Yeah.
So a midpoint is basically like a bisector.
A bisector is more than a point. So a midpoint is a point. A bisector is more than that. So a ray, a segment, a line, a plane that goes through the midpoint. From 1.4, you should be able to define angle, which is 2 rays that share a common endpoint. Acute, right, obtuse, and straight, knowing those 4 categories of angles. And adjacent angles. Remember with acute and obtuse particularly that you give both ends, so that acute is between 0 and 90, that we don't just say less than 90. Okay? We need to give the cutoffs on both sides for those definitions.
Are we allowed to do like 0 dash and then?
Yep, I'm fine with abbreviations and notations and stuff as long as I can tell what you mean. Questions on vocabulary? Okay, again, emphasize it's not going to be matching, and you need to write words, not pictures. You should be able to use a diagram to recognize collinear and coplanar points, remembering to look for stuff that's not drawn into the picture. So just because it's not there doesn't mean that it couldn't be there. So these are some true-false examples here. Our diagram is kind of like a shoebox again. But we've got a couple of extra points on the front of it, J and K. A, B, and E are collinear, true or false? False. If I try to trace out A, B, and E, I have to turn a corner. Collinear means in one straight line, so that doesn't work for those. A, B, and E are coplanar.
True.
True. They're all in the bottom of the box, so they are all coplanar. In fact, any 3 points are coplanar. So even without a diagram, if I just give you 3 points and say are they coplanar, they have to be. That's what one of our postulates said yesterday. Okay? 3 points have to fit within a plane. Once we bring in the 4th one, maybe yes, maybe no. So A, B, E, F. That is true. That's naming off the bottom of the box. But if I said A, B, E, D, that doesn't work, okay? I'd have to do some twisting to catch that other one. J and K are collinear.
True.
J and K are collinear because I could draw it in even though it's not drawn in. In fact, any 2 points are collinear because I can always connect 2 dots. That was one of our postulates from yesterday. Okay? So 3 points have to be coplanar, 2 points have to be collinear. I can always connect 2 dots.
We have to know which postulate.
You do not.
Okay.
You do not need to know the postulate numbers.
We just need to know.
The ideas of what they say.
True.
So like that we can connect any 2 points. A, J, D, and G are coplanar.
True.
True.
A, J, D, and G.
Yeah.
Yes.
Yeah.
Yes.
Because you can.
Yes.
Yes.
Wow, that's true.
It's not one of the drawn-in ones. But remembering
Drawn
that we
in,
can
oh my
draw
God.
in new
It could be
planes,
its own thing.
I can catch all those
I
points.
said, I don't know. I was like, go on.
All I heard was
Well, maybe
Okay.
you see.
Questions? You should be able to name angles and parts of angles and use algebra to solve for angle measures. So I gave some examples here of problems that you did for homework that will be similar to something that you could see on there, and then also some extra practice from the classroom exercises. In general, what you need to make sure that you are able to do is, if I give you a picture of an angle, that you can name that angle. When we name an angle, we grab a letter on one side, then the vertex, then a letter on the other side. It doesn't matter whether I actually call it C or D here. Okay? We only want 3 letters at most though, so don't name all 4 of them. A letter on one side, then the vertex, then a letter off the other side. To name the parts of the angle, a vertex is a point. It's the point where the rays meet. So what is the vertex of this angle?
B.
B, and that requires no symbol because a point, we just use a letter, it has no symbol. The sides of angles are defined as being rays. So we need to make sure we name them appropriately using appropriate symbols. Ray BC or BD is one side of this angle. What is the other side of the angle? EA. Remember when we name a ray, we start at the end point and then pick another point along that ray, and making sure to use the symbol above to show that we are talking about a ray and not a segment or a line. Okay. Questions on naming angles or parts of angles?
Is that our homework?
You don't have homework tonight. You actually already did all these problems on a homework assignment, so just be problems to review for practice. It says using algebra to solve. So in your homework from 1.4, you had a picture that looks like this. In the directions, we were told these 2 angles were congruent, and a lot of you had questions about these problems. We worked them together as we were going over the homework, and now I'm telling you, you should have hopefully caught that and be prepared to do it again for the test. So, for example, let's say you're told that this part is 4x and this is x. And I want to know what x is. Well, I know 2 angles here are congruent because of the marking. So that has to be x as well. And what do I know about all of that?
It equals 180.
Altogether, those 3 angles add up to make a full line of 180. 36x is 80 and x is 30. Okay? Or, what if I told you this is 4x plus 1 and this is 3x plus 5? What would I do to solve for x?
4x plus 4 equals 3x plus 5.
Oh yeah.
Since those 2 angles are marked as being the same size, I can say that one of the angles must be equal to the other angle. And then I could solve
X equals 4.
by subtracting 3x
3x.
and subtracting 1.
X equals something. X equals 4.
Showing work is really important for you. So when I grade a test, if there's a right answer there with no work, it will still receive full credit. But if there's a wrong answer and no work, it will lose all of the points that problem was worth. And sometimes problems may be worth 2, 3, 4 points. Whereas if you show me work and I can see you set it all up right, you did most of it right, and then on the last step, oops, you said 5 minus 1 was 3, you're now going to have a very small deduction, as opposed to if all I see is the wrong answer of 3. Then you would lose all of your points because I don't know what you did wrong. So if I can see where you went wrong, I can be very generous giving you points that you have earned with partial credit. But if I don't see it, I can't give it. I can't read your minds. So showing work is important to you if you happen to get anything wrong along the way. Okay? Questions on these types of problems? You'll have a portion of true-false questions that use the ideas from the postulates from yesterday's lesson and the concept of not trusting our eyes. So you do not need to have those postulates memorized. You need to know the general ideas there. I can always connect 2 points. 3 points are always in one plane. Okay? I need to know that I can't trust my eyes. So if I have a picture that looks like a right angle but it doesn't tell me it is, it's not necessarily a right angle. Okay? So I need to know that I need some sort of fact or that little box in the corner of the picture to let me know those kinds of things. for example, one of our theorems said that if two lines intersect, they intersect in a point. Okay, that's what one of our theorems said. If two lines intersect, they intersect in a point. So, true or false? Two lines must intersect in a point.
True.
Two lines must intersect
False. Oh wait.
in a point.
Wait.
True or false?
False.
Why is it false? I have a picture right there. They don't have to intersect. So this theorem tells us if they intersect in a point. But not every two lines are actually going to intersect each other. Okay? So if two lines intersect, they meet in a point, but two lines must intersect in a point, doesn't necessarily have to be true. Be careful with words like must or always or never. Those are very big statements to make. So when you see one of those absolute statements, always try to think, is there any other case where this might not happen? So it may happen almost always, but does it have to happen actually always? Okay, so always look for that other possible case. You should be able to do some drawings like we did in section 1.2 where we drew horizontal planes and vertical planes and intersecting lines and labeling our pictures. Then I'm giving you a very specific hint here of something to be prepared to do. You should be able to draw and write an example of angle addition. I'm not going to do this for you, but I'll show you what it would look like if I would ask you about segment addition, since that's almost the same thing. So our segment addition postulate. It says draw and write, so we need a diagram. So a diagram that would work for segment addition would be something like this. Since it's your diagram, you can use whatever letters you want. You can use your initials as long as they're all different. But you can just pick whatever letters you want. I need a diagram. It says draw and write. So now I need to say, what does this picture tell me? The segment addition postulate says that if I add AO and OB, I get AB. So this would be a sufficient answer if I asked you about segment addition. So now, while you're studying, prepare yourself to be able to do this for angle addition, which was in section 4, I believe. Okay?
So you're saying something, so that's segment addition.
That's segment addition. So
why
your
is
job
this-
is to
why is this-
figure out what does it look like for angle addition.
Oh,
Okay, I'm not going to give you the answer I'm expecting on the test, but I'm very specifically telling you one thing to make sure you look up and know. Okay?
What is the test?
I don't know how many questions it is, but it's like a front, back, and front. When I give a test or a quiz, I will not give any lessons or assignments on that day as well, so that everybody can have the entire class period to finish. Some people may finish much faster than others, but we'll allow for the entire time. So if you know that you are typically a quick tester, you might want to bring along with you some homework to work on when you finish it.